All right, so this is the most important part of this section here in 8.4. Determine the equation of the given graph. So now we need to pick out, we need to determine the characteristics of this graph. We need to associate those with A, B, C, and D. And then we need to put it into the format of the transformed sinusoidal graph that we have down here. So this is what this section's all about. So let's see if we can identify, we need to identify, A, all right? We need to identify B and C and D. So what do you think is going to be the easiest to determine? A? Okay. How do we determine A?
Max plus min over
Okay.
2.
Okay, max plus min over 2. What, is that the amplitude? Is that the midline? Is that the, what is that?
That's the amplitude.
So amplitude is max plus min.
No, I lied. It's
Max minus min? Okay, so, are you sure?
Yeah.
Okay, max plus min is the average of the two, which would be the midline, which that will come in handy later. But, so max minus min is the amplitude. So max minus min, 5 minus a negative 3 over 2. So that's 8 over 2 is 4. Okay, so if A is, let's see if that makes sense. So from the top, 1, 2, 3, 4. That should be the midline then. So let's see if it's the same distance down to the bottom. 1, 2, 3, 4. So that is correct. So 4 is our amplitude, so A is going to be 4. All right, so let's keep that in mind. That's great. All right, how do we figure out what B is? Let's just move down the list. B, what's B?
1 over B thing.
Okay,
Oh.
so, okay, right. There's a few ways to think about this. So how many complete cycles are there between 0 and 360, right? In this case, what would normally be 1 period length for a regular sine. Or what's the period length and what fraction of 360 is that? That's another way to think about it. I like this one though. The period length, PL, is 2 pi, or in this case, we're in degrees, so 360 divided by B. So the period length is 360 divided by B. Now we're pretty good at finding what the period length is. We did that last section. So I'm going to go from, let's see, we could go from, well, the y-axis, we could go from the y-axis here. Where is the corresponding point that is the same, like the start of the next one? So let's see if it goes down like this, it goes up. So I'm looking at this one. Do you like that? All right, I like that. So what is the length here between this, which is 0, and what is this number then?
120. No,
Each square is 30 degrees, looks like.
120.
So 120, very good. So that means that 120 equals 360 over B, or B equals 360 over 120, which is 3. Okay, so B is 3. Everybody agree with that?
Yes.
Very good. So let's just see if there's 1, 2, 3 in 360. Absolutely true. So we're going great here. All right, what about C? How do I know if this has been shifted left or right? And this is kind of tricky because it's repeated, right? It just goes on forever. So where is a starting point? Do you know what I mean? And this actually, there can be many different equations that represent this same looking graph. Now, I'm going to try and steer you towards what would be the simplest and probably the most straightforward for you to determine. So what I want you to do is to find out how far to the right or left do you have to move in order to get what looks like a perfect sine function. So if you start here, this is not a perfect sine function when it goes down first. But if you move over, let's see, move over to about here, this is where a perfect sine function starts. You see it goes up first, then down, and then back to the middle. Now, it might be a good idea to find out where the midline is, which is kind of what D is. The midline is right here, isn't it? It's 4 units down and 4 units up from the minimum and from the max or whatever. So that's actually pretty handy too. So if you look at that, then guess what? This right here is how far you have to go over to get a starting point for a sine. And that's going to be the most straightforward C value. Okay. So how many degrees did I have to go to the right?
60.
Okay, so C is actually 60. Come on, blue, please. C is 60 degrees. So again, how far from 0 did we have to move either left or right to get the first complete looking sine graph? That's your best way to see. Now, technically, look at this. Technically, you could have gone way over to here. Say, hey, that's the start of a good looking sine graph. Yes, you could have. So could C be 180 as well? Yeah, it actually could be. So that's what I'm saying. There could be many equations that represent the same graph because it repeats so much. So we're going to try and do this the simplest one. And if you happen to do one that's not the simplest one, as long as it's correct, I will mark it correct. Okay? But this, I'm just showing you how to find the simplest. So C is 60, excellent. And D is how much, really, where's the midline, right? Because in a sine graph, the midline is y equals 0. So the midline we said was at y equals 1. So guess what? This graph really has moved up 1 unit. So plus 1. Now that we've done all that work, it's pretty easy to put it into the format. So what is A? A is 4, so I put 4 in front of the sign. B is 3, so I put 3 right here where the B letter goes. And then 60, so I've moved this to the right 60. So what does that look like after the X?
Plus 60.
Ah, close. Yeah, it's actually minus 60. Remember, it's opposite of what you kind of think. So it's minus 60. Minus 60. All right? And then outside of the brackets for the D value is plus 1.
Okay.
So there's two ways you could write that now. Y equals 4 sine 3x minus 60 degrees plus 1. So you could write like that. You could also write it, guys, watch. You might see this in your textbook. You could also actually expand this out and write it like this. 4 sine, I don't think you'll see this much, but 3, you could multiply this in. So 3x minus 180 degrees. And that would be in the sine brackets there, plus 1. So there's two different ways you could kind of show that. But if you stick to the format that we have down here with all the brackets and stuff, that would be good. And yes, you could have a second set of brackets here, like I showed you at the beginning of class. You could do that as well if you want to make sure you're sure about things there. That's a good idea to do that too. Okay, any questions? Yeah.
Now I just made after.
Yes. Any other questions? Okay, you got her? All right.